Hello everyone, welcome back. In this lecture, we will talk about the concept of development. After solid, we will go for the development of lateral surfaces of the solid. Um, Here, what we're gonna do is we are going to cut a solid structure, and we- then we have to draw the or we have to develop the lateral surface of the remaining cutted part, or in other words, we have to draw the develop we have to develop the lateral surface of the truncated part. So for example, let us start with an example of a square cross section. For example, uh, this is a square cross section, as you can see, or in other words we can say it is a square prism. In the base we have a square face, and at the top we do have a square face, and these are the straight faces which are straight lines which are connecting the corners, the top corner and the bottom corner. This is the wireframe model, and this one on the right is the solid model with reflected edges. So now what we have to do, we have the square prism in which at the top we do have a square face, and at the bottom we have again a square face of the similar dimension as in the top. So you can see the top is square, bottom is square, and this if I talk about this side, this lateral surface, this one is face 1, which is a rectangular face. This is 2. Similarly, there will be another 3. There will be another, and one more, 4. Because we have a square at the top and bottom, 4 edges. So it means by connecting the top square to the bottom square, we will have 4 rectangular faces, which will make the solid body. So now the next step is we have a solid structure. Now I'm going to cut the structure with a 2D plane. For example, this is a 2D plane which is perpendicular to the structure. It means if it is perpendicular, suppose in the top view we have a square. If this is a square prism which is resting on HP and it is in front of VP, then in the top view we will have a square, and in the front view we will have a rectangle because it is greater in length as compared to any of the edge or this edge. So in the front view we will have a rectangle, and in the top view we will have a square. And if I'm going to cut the structure with a plane which is perpendicular to VP, it means if this plane is perpendicular to VP, so in the front view we will have a straight line. This plane is perpendicular to VP, that is why we will observe a straight line in the front view. And the next condition is this plane should be perpendicular to VP, and along with this condition it should be inclined at any angle with the HP. So the angle with HP can vary. So it depends on the question. In our scenario, what we're gonna do is here we are going to vary this angle with HP. Right now it is inclined at a certain angle with the HP. So it will look like this. But the stable condition was the plane should be perpendicular to VP. So this is how it will look in the front view. And suppose this is going to cut this thing, so this top portion will be removed from the front view. Now this portion is removed from the front view. Now we have the remaining, this is the remaining part. Okay, so this is the remaining part of which we have to draw the lateral surface. So again we have a square prism, and the square prism is cut by a plane which is perpendicular to VP but inclined at angle theta with the HP. So it is perpendicular to VP, that is why in front view we will have a straight line. This is a 2D plane. We do not have thickness in it. Now, plane of surface, you can say surface. So it is perpendicular to VP, that is why we have a straight line in the front view. Now, along with this plane is inclined at angle theta with the HP. So this plane is truncating the solid structure. Again, truncating is a similar word to the cutting of a structure. So this plane is truncating the structure at this point or at this line. So now this portion has been removed from the body, and this lower part just below this plane, we have this part is the remaining one. So now we have to develop the surface of this thing. Initially, you know, 4 rectangular faces are combinedly making this prism. So now we, here again after truncation we will have 4 planes, but they are cut at some angle. So what we gonna do is I can look here. So after truncation, this prism will look like this because it is cut by a plane which is perpendicular to VP and inclined at an theta, angle theta. So this is the final view of the prism, or in the front view we will have this kind of image. So what we're gonna do is we have to draw the lateral surface, or we have to develop the lateral surface of this remaining portion or this truncated part. So what we can do is, we know initially we have 4 rectangular faces which are making this prism. So this first rectangular face, for example, we have the height of this prism is about 100 mm and edge length is 20 mm. So this square is of side length 20 mm and the height of this prism is 100 mm. So now what we're gonna do, for this rectangular face, there are total 4 faces which are making this prism. So this rectangular face, so the dimension of this rectangular face are 100 by 20. So what we can do, initially we have to create a initial profile without truncation. So after truncation the structure look like this, but initially it is like this. So there are 4 rectangular faces. So just draw the 4 faces first. For example, okay. So first face is this one. The length is 20 mm and height is 100 mm. As you know, now there are total 4 faces which are of similar dimensions. So what I'm gonna do is I'm going to draw 4 rectangular faces of similar length. Again, this is 20 and height is 100. This one is third face and this one is fourth face. Now what I have to do, this is the initial profile without truncation, initial profile of this square prism without truncation. So out of this, now we know after truncation this square prism look like this. So we have to trace out the structure, lateral surface of this truncated part in this profile. So let's start with this point. We know, for example, I'm considering this as A, this one is B, behind this we have C, and this is the last point D. So this point represent, in front view, this point represent A and D. Oh, sorry, you can say it A dash and D dash, and this point here similarly represent C dash and B dash. So what I'm gonna do, if I consider this face first, AB, like this one face is A dash B dash. Now second face will be B to C, or you can, instead of these faces, this one is first, here right side second, back side third, and this left side is fourth one. Instead of this, you can use these edges. AB is the first edge, so I'm going to mark this A, B, this is the first edge. Now the second edge will be B and C. So B to C is our second edge, C to D is third edge, and D to A is fourth edge. Okay, sorry, this is D. And again, last one is D to A. This is the fourth edge. So now, after truncation, initially the structure is like this. This is truncated from some distance from the base. So after truncation, this is the body. So what we're gonna do is the A corner, the line joining this point to this point, or this A edge, the distance at which this A edge is truncated, we need to find this distance first. For example, this edge which is connecting bottom A to the top A, or you can say any other name or any other word. For example, this is 10, and this truncation part, this is truncated at a distance of 30. So now first one is at a distance of 10 from the base, second one is truncated at a distance of 30 from the base. So now, so this is 10 and this one is 30. So now let's start with this point A, or A dash, B dash, C dash, D dash, and again A dash. So A dash, this edge is truncated at a distance of 10. So mark 10 units here, or 10 mm here. So in this line, from start with this point up to here, we will have 10 mm here. This is 10 mm, and next point will be B dash. B dash is the edge at B dash is truncated at a distance of 30 mm. So this is 30. Again, C dash should be again with at a distance of 30. D, 20, D again at a distance of 10. Again at a distance of 10. Okay, now we have all the points. So again, this edge A, this edge connecting A and the top corner of the square face is intersected or is truncated at distance of 10 mm. So A dash 10 mm, mark 10 mm from the base. B is truncated at a distance of 30 mm, so from B mark 30. Again C dash is right on this point, so again 30. D behind this point A, or in this point we do have A as well as D. So from D, in D we have 10 mm, so this is D, D dash. So from the base 10 mm, and again last point is A, because these are the four edges which are making this square prism. So again back to the point A, which is again at a distance of 10 mm, truncated at a distance of 10 mm. So again 10. Now we need to just connect these points. Okay, right now I'm connecting it with the solid knives. There is a reason when we have to use straight lines or curves. It will depend on the geometry of the structure. So this portion, this is the lateral surface of the structure after the truncation. So this is the truncation part. So the lateral surface of this truncated part is this one, below this line, or this one. This is the lateral surface. Okay. So let's try to do this in AutoCAD. Now we have a square prism in which we have considered edge length is edge length of the square prism is 20 and height is 100. So if you have a square prism who have 20 mm base edge, then we'll have a square in the top view. Okay, so this is of 20 Now mark them. This is point A. D. Now from this top view, we'll have to create our front view. Again, the height of this prism is it is given 100 mm. Okay, it is getting too long. So, okay. I can just move it in the downward direction. Okay, so this is now I'm going to connect this one. In the front view, we will have a rectangle. So here you can see this is our top view, and this is our front view. And here this point represent this point is A dash and B dash. Both points are here. A is directly behind this B1. So in front view B is visible, A is directly behind this. So this point represent A dash as well as B dash. And similarly this point represent D dash as well as C dash. Now okay, right now we are just considering the base prism, base face of the prism. You know, in the square prism, we do have a square face at the uh, top edge, as top side, as well as a square face at the bottom side. So in the top view, we will have only a square. So we are here. I'm considering only the naming at the base face. So this is the base face. Now we know this height is 100 mm and this square is of 20 mm. So what I'm gonna do is, now as we have drawn the initially there will be 4 rectangles in which this prism is made up of 4 rectangular faces around these edges, whose length is 20 and height is 100 mm. So I'm going to draw first so this is our first face, height is 100, length is 20. Okay. Now our next step will be similarly we do have total 4 faces because this is a square prism. So this edge will represent first face, this edge and this side will represent first rectangular face, similarly second, third, fourth. So we do have 4 faces. So I'm just going to copy this, make copy of the square, because all of the faces are of similar dimension. Third, fourth. So we do have 4 faces. So this is the initial lateral surface of the square prism without any truncation. Now after truncation we have to draw this. So now for example we are considering like this prism is truncated by a plane which is perpendicular to VP. Only then it will look like a straight line on in the front view, and it is passing through the midpoint of this prism. So and the plane is passing through the midpoint of the prism, as well as it is inclined at an angle theta. So just from the midpoint I am going to create a line which is at an angle of 30 with the HP. So this you can see, oh, this 42.8. Okay, now according to our condition, the plane is passing through the midpoint of the prism, axial height of the prism, and the line is inclined at an angle of 30. Now check it again. This line is making an angle of 30 degree with the HP. Okay. So this is a plane which is perpendicular to VP. That is why we are observing it as a straight line. So just change it to the main drawing. Now I'm going to extend it up to the left edge, because we know this plane is truncating the whole structure, whole prism. So this is a point where above this line the structure is truncated by this plane. So I'm just going to remove this main drawing with the construction line, just to identify it as it easily, so that we can clearly distinguish between the truncated part and the main drawing. So this blue reason represents truncated part, and this is the remaining part of the truncation. So now we need to find out the little surface of this truncated part. So you can mark this thing. So I'm going to trace this thing from this point A. For example, I'm opening these four faces from this point A. So if I open this up, it will look like this. This one is A to B, B to C, C to D, and D to A. If I connect this point to this one, again it will become a square. So A, B, C, D, again A. If I join this point to this one, so again it will become square. So what I'm gonna do, just mark. Take it in the series, either from A to B, B to C, C to D, or you can take from here, A to D, D to C, C to B, or B to A. So I'm taking this clockwise direction, sorry, anti-clockwise direction. A to B first edge, B to C second, C to D, taking the consecutive edges. So just mark them. This one here is A to B, this is our first edge. Then B to C is our second edge. Then C to D, third edge. Then D to A, faces. So they are making four faces. Now the edge A is truncated at this distance. So you can either do one thing, just measure the distance from this point. This is 44.2. This edge is truncated at 44.2 mm, and this edge is truncated at a distance of 55.8 mm. Either you just do this thing from A. This is point A, so from A create a line at a distance of 44.2, or create an arc which is intersecting this line with a radius of 44.2, or this is a straight surface. So just you can do one thing, by placing this rectangle on the same reference line as on which we have this front view. So the base of this front view is here, so on the same reference line I am placing the lateral surface of this this part without truncation. Now instead of creating arc, I'm just going to do, this is intersected at this point, this is truncated at this point. So from here I'm going to draw a horizontal line, and we will start with point A. So here point A is truncated at this point, and so we are going to extend this line up to the A So this intersection point will give us the exact length as we have here. So this line is parallel to this reference line. So this distance should be equal to this one. So this is our first point. Now, similarly, we can do the second. We can go for the second point. So this is our point B. Sorry, again, B is on the same horizontal line. This is A, then B. So again, B is on the same horizontal line. So I'm going to extend it from here to here. This is point B. Now, point C is here, from here to here. So I'm going to mark this line just for to make it a little simpler. So I do not want to get confused here. I'm just going to make this inclined line. This is the first point from here to here. Second is here. So we have point C. So again, D is on the same point. So if I extend this thing from here to here, we will have our point D. Now, next point is A. Again, back to A. So A is starting from here. So again, extend this thing up to here. So this is going to our point A. So now connect this line here. Okay, remove these lines. So this is our profile for truncated part. So just change this to the main drawing so that we can easily identify it. We can easily identify which part is our lateral surface of the truncated part. Starting from here, A is truncated at this distance. Again, B is truncated at the same distance. This is B. C is a little higher. D again on the same length. A again back to the initial one. A. So this part makes, or you can say, this is the reason. This is the reason which represent the lateral surface of truncated part. And this part is truncated out from the body. This is our remaining part. So to identify this thing, I'm just putting a color to this thing. So this is our reason, this is the developed lateral surface of this truncated part. So this is how we are gonna do this question. And here we have used this straight line because we do have a straight face surface in which all are rectangular faces and they are not aligned. They are not at a, they do not have any curved surface. That is why we are using straight line. Instead of this, if there is a vertical cylinder or a cone, then you can imagine if we have a vertical cylinder, if I truncate that cylinder similar to this profile, then instead of straight lines here, we have to use curved lines because it is a circular part. So instead of straight lines, we have to use curves. So the best thing to use, the best tool to use to create the curve is spline fit, which is here, the left one. Extreme left one is spline fit. So instead of straight line, we have to use spline fit. Again, similarly for the cone, if it is right angle or at some angle, then again it is a curve profile. So instead of straight lines, we will use spline fit. Okay, thank you.